Okay, hi everybody. Welcome to the section 2.1 self-check exercises. So what we're going to do is just take a bunch of derivatives for some common functions. So remember now, derivative, it's the same thing as an instantaneous rate of change, but now we're looking at it in terms of general functions. And we are we have new simple tools and tricks to make the job more easy for us instead of doing a whole definition limit like this. Okay, so makes work a lot easier. So let's go ahead and get some practice in. So for number one, we want to find the derivative f prime of x for f of x equals -2. So f prime of x, that's the derivative. You need to write f prime of x. And this is just a constant, right? Right, it's just a number. There's no x or anything attached to it, no variable. So when that happens, the derivative is just 0. All right, constant rule. Now, number two, that's all the answer is. So now number two, find y prime for y equals 2x. Y prime just means derivative, right? Just different annotation, derivative. Okay, so find y prime. So y prime, meaning the derivative, here we just have a 2x. So when it's just an x, right? What's going to happen is that x just drops. And the derivative is just going to be that coefficient attached to it. And so it will just be 2. Okay, so if that's a little confusing, kind of remember that power rule, right? Power rule where, the derivative is, if you have something like x to the n, the derivative is n x to the n minus 1. So in this case, right, you have 2 to the x. But remember that we have this kind of like invisible first power right here, right? So if we take a derivative of that, that becomes 2 times 1 times x to the n to the 1 minus 1, right? Right, the power drops down and we subtract 1 from it. So this becomes 2 times x to the 0, but x to the 0, anything raised to 0 is always 1. So it'll be 2 times 1, which is just 2, which is the same thing we got. Okay, so this is really the long-winded way of why we get there, the reasoning. But whenever you just have an x, you just drop the x and it just becomes the coefficient attached to it, right? Remember that the derivative of y equals x, right? That's just going to be 1. Okay, so moving on to number 3, along that same lines, right? We have y equals -x. We want to find y prime. So y prime, remember, we just dropped this x. And what's attached to that x? What's the coefficient? -1. And that's it. Okay, so number 4, find dy over dx. That's just another fancy way to say derivative. Okay, that's a derivative. And so what we want to do here is find the derivative for all of these. So what we'll have here is y. I'll write y prime. I really like writing dy over dx too much, so I'll write y prime. But just a bunch of power rules, right? So this will be 10 times x to the 9th, right? Plus 7/9 times 9 times x to the 8th, plus 1/2 times times 8, x to the 7th, minus 5 times 7, x to the 6th, minus 1/3 times 6, x to the 5th, right? Important to keep track of everything. So now we just simplify and get our final answer. So can't simplify that. So it's 10x to the 9th. 7/9 times 9. These 9's cancel out. So it's just plus 7x to the 8th. And then 1/2 times 8. That's just 4x to the 7th. 35x to the 6th. and minus 2x to the fifth. And that's our answer. That's our derivative. Okay, great. So number 5 now, dy over dx for y equals cube root of x, x to the third power to the fourth root plus square root of the fifth root of 2. Okay, so one thing I want to make note of, notice that this fifth root of 2 is just a constant. All right, that's just a constant. So one thing I also want to do is kind of rearrange a couple of things. So I want to turn these roots into power so we can use a power rule. So kind of recall that, if you have some type of x to the a and it's a like x to the a be some type of b root, right? The way to rewrite this is x to the a over b, right? As a fraction of a power. Think about square root. Well, you know, square root of x is really just x to the 1/2. Okay, because you really have these first power, and it's called a square root because of that. You're taking the second root of it. So the way we write these would be, think about this being a 1 right here to the first power. So this would be x to the 1/3 plus x to the 3/4 plus, and we could just leave this alone because it's just a constant. We don't have to worry about it too much. And so if we take the derivative of this, we're just going to use a power rule, right? We're just going to drop these guys down, subtract 1 from it, and do the same kind of business. So y prime is just 1/3 x to the 1/3 minus 3. Well, that's negative 2/3. I mean, 1/3 minus 1, that's negative 2/3. Plus 3/4 x 3/4 minus 1, that's negative 1/4. And this guy is just a constant. It's just a number. So what it ends up being is just 0. Derivative of a constant is just 0. Okay, so one thing we can do to clean this up a bit is just make the exponents positive. Positive exponents is just a cleaner look. So to make positive, remember from our chapter 1, or sorry, our algebra review, the way to make exponents positive is you either move them to the bottom or the top, like numerator or denominator. So these guys are in the numerator. So to make them positive, I'm going to move it to the denominator to make that exponent positive. So what this becomes is just 1 over 3x to the 2/3 plus 3 over 4x to the 1/4. And that's it. So that's the answer to that one. Okay, next one, number 6. Find ds over dt for s of t equals 10 root t plus 5. So same exact thing, different variable though. We're using s and t, but it just means the same exact thing. So what I want to do is rewrite this square root here to a power with the fraction, so I can use a power rule. So this becomes s of t equals 10 times t to the 1/2 plus 5. So that means a derivative of this would be 10 times 1/2 t, and 1/2 minus 1 is going to be negative 1/2. And then the derivative of 5 is just 0 plus 0. Okay. Then just simplify this out. We get 5t to the negative 1/2, right? And so remember, I want to make this positive. So what I got to do is move it down to the denominator. So what this becomes is 5 over t to the 1/2. And this is okay. But if you know it's just a square root, you can write 5 over square root of t. So either one of these is okay. That's how you would do number 6. Okay. Moving on to number 7 now, right? If f of x equals 1 over x plus x 2 plus 1 over x to the 3, find f prime of 2. So now what we got to do is find derivative and plug in 2. Plug in x equals 2. But first we got to find the derivative. So the derivative of this guy, right? I need to use a power rule, right? So I can't use a power rule if these guys are on the bottom. So same thing with the exponents. What I can do is actually bring these guys up, make their exponents negative, and use the power rule. So keep in mind this is to the first power, right? So if I'm going to bring all these guys up, I'm going to rewrite this as f of x equals x to the negative 1 plus x to the negative 2 plus x to the negative 3. All right. When you bring these guys up, their exponents become negative. So now we can use the power rule. So the power rule, right, would be bring this guy down, subtract 1. Be careful with the negatives. You are subtracting 1 from it. You're not adding 1. So what this becomes is negative 1 x to the negative 2 minus 2 x to the negative 3 minus 3 x to the negative 4. Okay. And so once again, we got pretty much have a derivative, but we like to kind of clean it up a little bit by moving these guys to the bottom to get positive exponents. So we're just going to move them back down. So what this becomes is negative 1 over x squared minus 2 over x cubed minus 3 over x to the fourth. And that's our derivative. Okay, just notice in all of these, one way or another, we're just using the power rule over and over again. Different ways to go about it, but we're just using that power rule. So let me kind of make a note of that. Power rule, you know, x to the n becomes n x to the n minus 1. Okay, so number eight is kind of a longer one. So let me go ahead and work through that right now. So letter, remember for equation of a tangent line, right? We have a couple of things. We need to find the slope and we need to find a point and we need to find the equation of a line, right? So there's always really a step-by-step process to finding equation of a tangent line. So let's go ahead and do that. So step number 1 is find the derivative. So 1, find the derivative f prime of x. Okay. Step 1, so we have f of x equals 2x squared minus x plus 6. And the derivative of that is just power rule, right? It's going to be 2 times 2x minus 1 plus 0. So that's just 4x minus 1. So that's our derivative. Okay, so that's our first step, right? So second step is going to be plugging in this point right here, x equals negative 2. We're going to plug that in because that's going to give us that slope. That's going to give us that tangent line slope. So step 2 is find that slope. Find the slope, meaning you're plugging in negative 2 to what we just found. So remember f prime of x is 4x minus 1. So I'm going to plug in negative 2. So I get 4 times negative 2 minus 1. This is negative 8 minus 1, which is just negative 9. So negative 9 is our slope. Oops. So that is our slope. Okay, so that's step 2. Now step 3, what we need to do is find a point. So I need a point. Need a point x comma y. So I have my x value here, -2, because that's what we're trying to find everything at. So what I'm going to do is plug in this x equals -2 into this function here to get a y value in order to get uh get to find the equation of a line. So let me go ahead and find that y value. So f of -2 is 2 times -2 squared minus -2 plus 6. So this is 2 times 4 plus 2 plus 6. That's 8 plus 2 plus 6. And that's just 16. Okay. So last thing we got to do, remember, we're finding the equation of a line, right? What's the equation of a line look like? That is y equals mx plus b, right? That's what we got to look like, right? So we have a couple of things. We have a slope, right? We have our m, we have our two, we have our point. So let's go ahead and finish this out. So step 4 is find the equation. Find the equation y equals mx plus b. All right, so if you recall from our algebra review, there's really two ways to find the equation. It's with, y equals mx plus b, you find the y-intercept, or it's Point-Slope formula. So I like to use Point-Slope formula just because it's a little easier to use. So point slope formula, right? And that looks like y minus y1 equals your slope m times x minus x1. So here we have our slope, which is m -9, and we have our x1, right? The point we're checking now, which is -2. Sorry, excuse me, I forgot to finish this part off. Um, so this was your point -2, 16. And we have our point. So that means y1 would be that 16. So we have all these together. We just throw them into the point slope formula and we get our answer. So y minus 16 equals -9 times negative x minus -2. All right, we just simplify this out. Y minus 16 equals -9 times x plus 2. So y minus 16 equals -9x. Right, I'm distributing this guy in. -9x minus 18. And now I'm going to add 16 to both sides. That cancels out. And so what I'm left with is y equals -9x minus 2. And that is the tangent line equation. Okay, so this one's a couple steps to go through, but putting together a couple of things we learned already, like finding a derivative, plugging in an x value into derivative to get some type of slope, grabbing a point, right, that we're talking about. We're talking about -2, so we want that point at -2, and then just putting it all together using an equation of a tangent line, which is just some algebra review, and we should get our equation right there. Okay, notice that it's y equals mx plus b. Okay, so that's it for that question. And let's go on to this last one where it says the function w of x equals -0.006 x cubed plus 0.233x squared plus 1.86x plus 19.18812 approximates the percent of total investment of winery of size X in cases of wine produced makes on cellar equipment. Find and interpret W15 and W prime of 15. Okay, so for part A, what this is asking is plug in 15. Plug in X equals 15. Okay, so what we want to do is find the percent of total investment a winery of size 15 makes on cellar equipment. So we want to find that percentage. So for part A, right, I need to plug in 15. So W of 15 is negative 0.006 15 cubed plus 0.233 15 squared plus 1.86 times 15 plus 19.812. All right. So now it's just a matter of simplifying this out. So 15 cubed is going to be, if you just put in your calculator, is 3375 plus 0.233, and 15 squared is 225 plus 1.86 times 15. I haven't simplified that out, plus 19.812. All right, so if you multiply all these guys out, what you get is negative 20.25 plus 52.425 plus 27.39 plus 19.812. And if you add all these up, you should get 79.377. All right, so what does this mean? Oops, 1 second. So what does this mean? This means that the winery, right, we're interpreting it, the winery invests approximately 79.377% of its total investment on cellar equipment if it produces 15 cases. Okay. So that's part A, right? We're calculating it and we are interpreting it. Okay, so now let's check it out at 15 cases, but with the derivative. So what does that mean? So for B, you got to find the derivative first. So W, like first, need to find W prime of X. So W of X is negative 0.006 X cubed plus 0.233 X squared plus 1.86 X plus 19.812. I want to find a derivative of this, right? So it's just power rule. So the derivative of this is just negative 0.006 times 3x squared plus 0.233 times 2x plus 1.86. The x just drops, and then plus 0. Derivative of a constant is just 0. So let's go ahead and simplify this more. So this becomes negative 0.018 x squared plus 0.466x just plus 1.86. Okay, so remember we want to plug in 15, right? That's what the question's asking. So now we just got to plug in 15 into this derivative. So W prime of 15 is negative 0.018 times 15 squared plus 0.466 times 15 plus 1.86. 826. No, 86. Did I write that wrong? Wrong? Should be 1.86. Yes. Okay. All right. So now it's just once again simplifying. So 15 squared is 225. And then, you know, rewrite this out a bit plus 1.86. And so this becomes negative 4.05 plus 6.99 plus 1.86. All right, so what this comes out to is negative 4.05 plus 6.99 plus 1.86. That is 4. Oops, what's going on? 1 second. Okay, sorry about that. My pen stopped working. But if we all these together, we get 4.8. Okay, so okay, we get 4.8, and that is our answer. So what does that mean in terms of the question? So when we're talking about a derivative, it gets a little more complicated than just you know, and I don't want to say complicated, it gets more languagey than just normal. Like if they invest, if they have 15 cases, it's just that much percent. What we're talking about is really like one more talking about in the future. So what this kind of means is, the winery invests an additional 4.8% of its total investment on cellar equipment in producing the next case of wine. Okay, so when we talk about the derivative and instantaneous rate of change, is when we talk about that interpretation, it's really like, okay, well, if they have an additional, right, the next case, right, sort of that margin. We'll definitely discuss this more when we start talking about more derivatives, but yeah, the interpretation just if they invest an additional 4.8% when they produce the next case of wine. Okay, the next case, that's how much they're more they're producing in percentage. But okay, so that's it for the self check. See you next time. Thank you.